Able to see the screen? Yeah.
Yes, sir.
Okay. So, whenever we design fire alarm system, we basically use this IS 2189. So this is the basic BAS code that we do Indian standards. This particular code we use it for determining all the detectors. So in BAS, especially for location of fire alarm, even with my colleagues, I had a lot of because there are actually 2 points in this fire alarm system which is contradicting each other, which I'll be explaining you further. So most of the consultants will take a safer approach where the density of the detectors are more. Okay. So first we'll have a discussion on your detector. So that's probably page number 17 or 16. You'll have it. Yeah. You can see this. Okay. So 6.3 clearly gives the sitting in spacing requirements of detectors covering in general areas. Okay, so this particular one is the 6.3 is quite important for us. Okay, so in this, you can clearly see the height considerations at which you have to look at. So sitting in spacing, you can read 6.3.2a under flat ceiling. Whenever you've got a flat ceiling, the horizontal distance between any point in the protected area and the detector nearest to that point shall not exceed 7.5 meters in case of smoke detector and 5.3 meters in case of heat detector. So in simple words, summarize it. What he meant to say is you have to, any part of the ceiling should be within 7.5 meters for a smoke detector. Am I clear? Under flat ceiling, the horizontal distance between any point in a protected area and the detector nearest to that point shall not be exceeded 7.5 meters. That means, I mean, your seal in NFP, it will clearly be written as any part of a ceiling, it will be written. The words are, the terminology is a bit different. That's it. But anyway, generally, it will be 7.5 meters in case of smoke detectors. So, when you draw a circle for a detector, you can draw a radius of 7.5 meters and make sure that the total ceiling is being covered. Understood?
Yeah. Yeah.
Yeah. In first, we'll do this condition and then we'll go to the other condition, which basically gives the distance between the detector, which basically there's a clash between these 2 points. That means the first point, what I've read, and the next point, there is a small, I would say both are not determining the same. So a lot of people will have arguments on this again. In case of sloped roofing or a pitched roofing, when the distance between the top apex and the bottom of the roof exceeds 600, spacing of the detector in the vicinity of the apex may be spaced between 7.5 and 8.5 meters for a smoke detectors. Apex is basically the top of that particular one. So when you say, when you have I would say whenever your roof is something like this, when the gap between these two elements, if it is like in roof exceeds 600 spacing of detectors are on the vicinity of a spacing between 7.5 to 8 meters for smoke detectors. That means when you take this particular guy, when you measure it, you should not take the distance like this vertical way. When you take it, it should not exceed seven. I mean, it should be 7.5 to 8.5 meters. It should be understood. The distance is same. It is telling when you have a sloped roof also, you have to take that particular distance, nothing else. Clear?
Yes.
Then detectors shall not be mounted within 500 of any walls, partitions. So that particular one, we call it as dead space. That means whenever you've got a wall, let's say, this is your wall and this is your ceiling. So whenever you have a detector, your detector, the minimum gap between your detector and the wall should be 500 It should not be it should not be lesser than that. Because when smoke arises, it will have certain velocity, right? So what will happen? Most of the smoke will not be going to the corner. It will, because the molecules will hit because of the velocity, it will divert. So you will have certain gap which doesn't, I mean, smoke doesn't get accumulated in the corners that fast. So if you keep it there also, it's of no use, right? That particular detector. For that reason, the minimum distance is 500 Am I clear?
Yes.
Then coming to the next one is where the partitions of the storage racks reach within 300 mm of the ceiling, they shall be considered as the walls that extend to the ceiling for the purpose of sitting of detectors. That means, for example, you've got a warehouse. Let's say you have a warehouse. In this, you have a rack which is going, and from the ceiling, the gap is lesser than 300 mm. If the gap is lesser than 300 mm, do you think the smoke here, if there's a fire, the smoke can enter in easily into this location?
Okay.
Obviously not, right?
Yeah.
So if the gap is lesser than 300, you consider this as a partition itself. Don't consider it as like, an object. So this zone is separate, this zone is separate for you. Understood?
Yeah.
And
What
then
if,
similar, yes,
sir,
tell me.
what if it is greater than 300?
Then you need not consider it as an object itself. For example, if it is greater than 300 mm, if you have something like this, then this whole area is single for you. So this entirely you will take as a single room itself.
Okay.
Understood? So the whole, I mean, this elevation, by the way, so the whole space you'll take it as. Understood or not?
Yeah. Sir, in case of triple height or
See,
yeah,
if
in
it is
case,
more than 10 meters, you can't use smoke detectors. It's of no use. You have to use beam detectors. That's the reason yesterday, if you remember, I've introduced you even
uh,
beam detectors.
okay, even
Clear?
in the case of triple height, the beam detectors can be used.
Yes. The triple height also you can use beam detectors. Yes. On the top you can install it. Nothing wrong with that. Up to 10
Okay.
meters, yes, you can use your smoke detectors or heat detectors. More than that, you can't. Of course,
Okay.
heat detector is much lesser. Yeah.
In sprinklers, we have this side throw sprinklers right now, sir. In the same
Right.
way, do we have any side smoke
No, no,
detectors
no.
on?
Detections, it's of no point because if you install it on the side, also, as I told you, you'll have something dead space where smoke wouldn't
Mm.
enter. So there's no
Oh,
point in this. So instead, we'll go for beam detectors. Simple.
okay.
Understood?
Yeah.
Okay. Then coming to the next one is similarly, if the ceiling obstruction such as structural beams deeper than 10% of overall ceiling height shall be constituted as walls for the purpose of setting of detectors. That means, let's say your building height is 4 meters. Okay, building height is 4 meters. So in that, if your beam is, let's say this is your beam, if your beam height is greater than that particular, greater than 10% of 4 meters will be how much? Hello, 450 mm alva. 4 meters means obviously it
Yes.
will be 400 mm,
Mm.
right? So when you have the beam height as 400 mm, then you consider this space is different, this space is different. Yeah, but this rule
Oh,
generally people wouldn't follow. But yeah, because anyway you've got a false ceiling to take care of it. That's the reason. Am I clear?
okay. This in the
But for
case of
exposed
false ceiling.
slabs, you'll take this particular one. But in case if you have a false ceiling, if the space between ceiling and slab is lesser than 800, you need not install a detector, assuming you don't have any combustible materials. Cables are okay because generally we use this nowadays as FRLS cables only most of the cases. But if you consider, if you, I mean, most of the cases, this civil case, they'll use this wooden pattas and all for the supports of gypsum board. In that case, again, you have to. That means you have some combustible material. But if you do not have any combustible material, then you can ignore it. If it is more than 800, in this particular space, your beam anyway becomes 99.9%. Your beam anyway becomes greater than 900 mm, alva. I mean, greater than 10%, it will become, right? Hello.
Yeah.
So, according to the beam layout, you will place your detectors. Understood? I mean, if the space is greater than 800 mm, if it is lesser than 800, you need not install the smoke detector. That is clearly mentioned in the IS code, which I'll be showing you shortly. Understood or not?
Okay.
Understood. Right. Then coming to the next one that we have is detectors shall not be mounted within 1 meter of any air inlet. That means if you have a HVAC, your supply duct, especially return, you can because it's actually good. because moreover you're trying to take an air sample. If you have supply air, then within 1 meter you should never place your detector. Adjacent to return air, you are always free to install, but for supply air you should not. Clear? Then coming to the next one is detector setting shall be such a way that a clear space of 500 mm is maintained below each detector. That means if you have a detector, if you have a storage rack or anything, at least the height should be 500 mm. Am I clear?
Yes, sir.
Lesser than 500, you should not have it. Where detectors are constrained to be fixed on the wall, they shall be sited in such a way that the top of the detector element is between 150 to 300 mm beneath the ceiling. And this we don't use it at all. As I've told you, anywhere we should not install between 500 mm as per the other clause. There is something called as a dead space. Detector shall not be mounted within 500 mm of any wall or partitions. Right. So generally we don't use this particular one. This is again the clause, because I've never seen even a detector which is mounted on the wall, or no consultant will generally show it over the wall. Only beam detectors will be installing it on the wall. Okay. We're ignoring this. So these are the main rules that you should follow. Clear? You understood about the location of the detectors or not?
Yes, sir.
Yeah.
But along with this, there's one more clause which basically gives height compensation for spacing of detectors. That's basically between the detectors, the spacing is what it's speaking about. Spacing of 7.5 meters of detectors is valid for a height up of 7 meters only, and that of 5.3 meters for heat detectors is valid up to a height of 5 meters. Beyond these heights, the spacing between the detectors shall be adjusted as follows. That means what it says is up to 7 meters in case of heat detector, smoke detectors, you can have a spacing of 7.5 meters between the detectors. But this is what I've said. There's an argument always with everyone. But what it clearly says is spacing of 7.5 meters for smoke detectors is valid up to a height of 7 meters. That means up to 7 meters height, you can have between two detectors, you can have a space of 7.5 meters, right?
Sir, this 7.5 meter is radius, right?
That's what. So now it becomes not the radius, it becomes the distance between two detectors in this particular point.
So 7.5 will be diameter now.
Right, obviously. Not exactly. Basically, what it says is between you have to give a maximum gap between detectors is 7.5 meters.
Okay.
But in the previous case, what I've explained, they've clearly said 7.5 meters is a radius, which is as per NFPA, because this particular part is not there in NFPA. Only in NFPA, the distance between any part of a ceiling to the detector is what they'll clearly mention, which is valid anyway. Understood? So most of the consultants, what they do is, irrespective of the type, they'll consider the distance between two detectors, they'll take it as 7.5 meters in form of grid wheel, basically draw it. Understood? To avoid this confusion. Because between two detectors, if you place 7.5 meters, then what will happen? Anyway, any part of the ceiling will definitely be lesser than 7.5 meters, Alva.
Yeah.
That's the reason we do this exercise. What if the design code is designed as per NFPA, then you will not have this particular rule. Only distance between the ceiling and the air velocities will come into picture there. Am I clear?
Yes, sir.
Okay. And valid up to a height of 5 meters. So, and one more thing is, heat detectors up to you will have only that of a 5.3 meters, but is valid up to a height of 5 meters. So, heat detectors, you will install it only up to a height of 5 meters, and the maximum distance between two detectors will only be 5.3 meters. Understood?
Yes, sir.
Smoke detectors between 7 meters. That means if your height of the slab is greater than 7 meters and lesser than 10 meters, 5 meters spacing you will use it. Instead of 7.5, the distance between two detectors will only be 5 meters. Understood or not? So if your height of
Yes.
the bottom of your false ceiling to the floor is up to 7 meters, your distance between two detectors will be 7.5 meters. If your distance is above 7 but lesser than 10 meters, your distance between detectors will only be 5 meters.
Sorry.
If
Yeah.
it is above 10 meters, then you will have your beam detectors only will be used, or aspiration, that Vesda system I told you, right? That will be used. Am I clear?
Yes, sir.
Then coming to the next one that you have is heat detectors. So heat detectors between 5 meters and 7.5 meters, 7 meters, you will have 3.5 meters spacing. Generally, it will be 5.3 meters. If it is 5 meters, if it is above 5, lesser than 7, you'll have 3.5 meters spacing. Beyond 7 meters, we shouldn't install any heat detectors at all. There's no point in installing a heat detector. Am I clear? That means if the height increases, the density also increases. Understood or not?
Yes, sir.
Clear?
Yeah.
Okay. Then coming to the next element that you have is high air movement consideration. The space between shall be suitably reduced. I mean, there is one important table that is sufficient rest all is not required. Not this one. Yeah. So basically, if you have high air movement, then generally we have this HVC system, alva, right? So inside your building, you know the total AHU capacity. So the AHU, what does it do? It removes the air from the system. It lacks some amount, like, minor amount of fresh air, and again it will dump the same air into the room space. You agree?
Yes, sir.
So that particular one, we basically call it as air changes. So I'll just explain you a small thing here. So air changes is nothing but total number of times you're changing the air inside the room space. Understood? So I'll just give an example. Let's say I've got a room space of this is length is, let's say, how many. Okay, I'll just give an example here. So when you have this particular one of air changes, let's say I've got a space of so let's say I've got a room space of 20 feet by 30 feet by height, let's say, is, for example, some 9 feet. What are the false ceiling? Right. So this is the room space. Okay. So cal 20 into 30 is how much? That's around 600. Cal 600 square feet divided by 150 SFT is approximately 4. Okay. Let's say I've got a tonnage of 4 TR AHU, 4 TR AHU, 4 tons AHU with an airflow rate of 1600 CFM. So CFM is cubic feet per minute. That's a volume of air. You might have seen it in HVC drawings, right? Okay. So now I've got a space of 20 feet by 30 feet by 9 feet is the room volume. Now I know that I've installed a 4 tons AHU in this. So how do I calculate air changes is volume, I mean air changes per CFM is equal to volume into air changes divided by 60. Okay. So what do you mean by this is simple. Number of times you're changing the air into volume will give you the total volume of air or not. For example, per an hour, you're changing 10 times. Total volume into 10 will give you, total volume of the air into 10 times will give you the total volume it is circulating in an hour or not. Simple calculation.
Yeah.
That divided by 60, if you do it, you will get per minute volume. Yes or no?
Yes.
So
Yes.
the formula is simple. Just a sec. Yeah. So here the volume is basically volume is area into height into ACPH divided by 60 will give you the CFM. Understood? But in this case, we already have CFM alva. STL already 1600 CFM is the total volume that we volume of the air that 4 TR ductable unit is discharging to the room space alva. So
Mm.
in Madbeko, we already have 1600 CFM is a CFM that we have it. So volume is equal to this particular guy into so now I have the CFM. So air changes, if I want to calculate, what should I do? Is equal to this into 60, right? Divided by area into height. I can do it or not?
Mm.
So how much is the value? What is the value? 30 into 20 into 9. 30 into 20 into 9. So that will basically give me 17 air changes. Understood? So I have an air changes of around 17.7 or 18 around a round up to 18 air changes. Understood or not?
Yes,
Is
sir.
it clear for everyone?
Yes, sir.
Right. So if I have this 18 air changes, now what I have to do? So lesser than 7.5, 18 air changes means it is 15 and 20 or not?
Mm.
So if I take it, what I have to do is my area coverage, if I take it, the spacing I have to multiply with this particular 0.64 to be safer. So we'll take the spacing of 0.64. That means 7.5 into 0.64. Of course, 99% of the consultants or fire alarm system, they don't even consider these things because generally HVAC consultant is different guy and this guy is different, right? So both will be parallel. So by default in India, they always consider 7.5 meters as the distance between two detectors and execute it. But technically, if you see, that is not the right way. You have to even see the air movement and then you have to work on the system. Am I clear? Understood or not?
Yes,
Yeah.
sir.
So
Yeah.
now the spacing will be how much? 7.5 into 0.64. So is equal to 7.5 into 0.64. Then it will be 4.8 meters. The maximum distance between two detectors will only be 4.8 meters. Understood or not? But I would bet almost 90% of the consultants, no one will do this exercise. Directly 7.5, 7.1, that's it. But it's a wrong way of approach anyway. In the NFPA, they'll be clearly be specific about it. Understood? Yeah.
Okay.
Of course, in IS codes also is there, but as I've told you, lack of knowledge or lack of like because because designers, I mean, you're already in design tree, right? You can observe. What is happening? See, you are a plumbing consultant. You have a separate team for fire, separate team for HVAC. So this common knowledge, very few guys you have it in bigger firms. So now you guys will design with 7.5 meters in most of the cases. The same thing will be copied by everyone. Or like, it becomes a general norm in the industry. No one questions about it. Understood? But anyway, technically, if you ask me, you have to consider air movement and according to that, you have to place the detectors. NFPA, they clearly mention these all things. Clear?
Yes, sir.
Okay. So this is where you have to take it, and of course you can always download. Anyway, I'll be sharing you, but you can download online as well. You can create a free, account with BAS, and you can download any this thing. You have the website for BAS or not? Hello. So any standard of BAS, you can always download it. You always get even related to plumbing as well. So I'm just uploading it in the group. You can always log into the website and you can download any standard for free. Okay. Anyway, so these are the basic things on your detectors, which is sufficient for most of the 90% of the cases. So we go to the next topic, which is your MCP.
Yes, sir.
Okay. You can see this particular one. So 6.3.8 will basically give you about the manual call points. So by the way, till now, is everyone clear or you've got any queries? Chetan and Madhu? Hello.
Yes, sir.
Yeah. Madhu, is it clear for you as well? Hello. Is that online? Okay. Okay. So you've got manual call points. So manual call points is clearly mentioned here, right? Manual call points shall be located that to give an alarm, no person in the premises has to travel distance more than 30 meters to reach them. When the manual call points are also installed external, generally we don't install it if it has given, but it's not mandatory that we provide external. The travel distance shall be 45 meters. Okay, that means any person in the building, they should be able to reach your manual call point within 30 meters. Am I clear or not? So you have to place your MCP in such a way that you should be able to travel in a distance of 30 meters. And it's always mandatory to install for fire exit staircases. Understood or not?
Yeah.
Only at the
Okay.
fire exit staircase, right?
No, not only at fire exit staircases, because fire exit staircases distances can go even up to 45 meters in case of sprinklered building.
Okay.
But your MCP should be within 30 meters. It is independent of sprinklered or non-sprinklered building.
Mm.
Clear?
Yes.
Okay. That in passive firefighting, when I explain about fire exit staircases, you'll be clear on that. Then
Sir, this can be placed along with this FHC, right? Means even that is a distance of 30 meters we are going to
which
do it,
one?
right? FHC.
Fire hose cabinet, not everywhere because it might not be feasible in most of the cases.
Okay. Even that
Yeah,
traveling distance is 30
is
meters.
also 30 meters. Yes,
Yeah.
absolutely. Yes, near that you can install. There's nothing wrong with that, but at least keep some maintain so that you'll be able to reach that point easy.
Okay.
Understood?
Yes.
Okay. And then always remember, you should install it at a height of 1.4 meters, but most of the people take the switcher site as 1.2 meters only and install practically. But as per IS code, it needs to be a height of 1.4 meters from your finished floor level. Understood?
Yes.
Okay. These are the main thing that you have on your MCP. No, nothing else is required for us for design point of view. Clear? Rest all is manufacturer spec anyway. So this is your MCP, and the last one is Hooter. Yesterday I've just explained you the components. Today we're going to have a discussion on this one. There is a particular one on dB noise level. Yeah, you can see it. So you can see this particular one. The sounders of fire alarm should be electronic to the frequency and all. So these are basically the frequency with which it is basically making the sound, 100 to 1000 hertz. But the distribution is really important. A minimum sound level of 65 decibels. Yesterday, you remember I've told you you have to give a minimum of around 75 decibels. Yes or no?
Yes.
Yesterday, while explaining the hooters, I told you 75 to 80 decibels is what you have to provide it in any space. You remember it?
Yes, sir.
Okay, but here it is 65 meters. Let me complete it, then you'll understand why I've said 75 or 80. So minimum sound level of 65 decibels, you have to maintain it, or 5 decibels above any other noise, which likely to persist for a period of longer than 30 seconds. That means if you have any noise with this 30 seconds or more than that, that particular sound plus 5 decibels you have to add. That you compare it with 65 decibels, whichever is higher that you have to take. But if someone is sleeping, the minimum noise level should be 75 decibels. Understood?
Mm.
So we really don't know in any space that we design whether like in an office also people might tend to sleep, right? So by default, we take it as 75 or 80 decibels. That's the reason. Understood? Of course, this is especially for your sick rooms or dormitories or any places where people are sleeping, to be precise. But generally, what do is we take 75 decibels as a norm in the industry. Clear? But technically, if someone argues as why this is office, it's not for sleeping, you have to, it is 65 decibels only, you have to accept it as well. Clear? So like this, you have to place your hooters. Understood. But in industry standard, not even that, what they do is wherever MCP is provided, above that, we generally try to place your router as well. Generally, it
So
will be
this is
sufficient, is what people
also like,
say, but need not be true. You tell me?
is there any consideration for this also, like certain distances we have to place?
No, there is no rule such that. The only rule is it should not exceed beyond 120 decibels because it will create a permanent damage for hearing. At the same time, it should not
Okay,
be lesser than 65 decibels or
65.
average noise level plus 5 decibels.
Okay.
That's the only rule. Clear? Okay. So this is a short note on the IS code, which is really important for us for determining the design of that. Now, shall we start with the design work?
Yeah.
Yes.
Okay, just give me 2 minutes. I want to have some water. Just a second. Okay. Now we'll be working on the next element, which is your this is- okay. Hmm. We'll be working on the next element, which is your design part now. So we'll open some project for which we'll discuss just a second.
Sir, do we have any restriction area for detectors, sir? Like while the sprinklers are not used in electrical room.
No, detectors, there's
Uh,
nothing as such. But yeah, we will not use this kind of detectors, especially in kitchens. We'll go for heat detectors rather than smoke detectors. In electrical room, we can use multi-detector, obviously. Okay. In pantries or kitchens, we'll use heat detectors rather than your smoke detectors. That's the only condition that we have. And if you have
okay.
dusty environment, then there's no point in detectors because detectors will, in that we use something called as a VESDA. Either I'll try to cover it today or if not, we'll work it on the next lecture. Okay.
Okay.
So
Yeah.
there is something called as VESDA, very early smoke detection aspirator, where you'll have a tube with the kind of like, small, what do you call, pinholes on a tube with like, with some sampling point, we call it as. Through sampling point, it will suck the air. Okay.
Okay.
So yeah, you have that particular application. Understood?
Yes.
Okay. So now we're going to continue on this sprinkler system anyway. Data design jobs. So, not design jobs, personal training, Alva. Yes, because I've made a HVC layout for them. So using that, I mean, that's a simple office that I've created where we worked on a heat load and a HVC design. So shall we take this as an office condition for which we'll work on the design of your placing of your sprinklers? Is it fine? Sorry, not sprinklers, or detectors? Yeah. Hello.
Yes, sir.
Yeah. Okay. And of course, exclusions I forgot, man. Really sorry. That also I have to, when it is not required. That is also important, right?
Yes.
Obviously, you shouldn't propose where it is not required at all. So there is something like exclusions, probably the heading, but exclusion. Okay, it's not written as exclusion, not required or something. Okay, just a sec. There should be some value where it's not required. Is 800 is what I clearly remember. Yeah. So here you have it. Comment also all these things we have done it, right? So in the same thing, you have this one. Voids in false ceiling or flooring more than 800 shall be protected with detectors with a spacing like a normal installation. However, voids in false ceiling floor less than 800 need not necessarily have an independent coverage unless the void in such a way that the spread of fire products between the rooms and compartments take place through it. Understood? Am I clear?
Yes, sir, but
Yeah. Yes, tell me.
yes, sir, that's what I'm reading.
Okay.
Okay. This talks about inside the false ceiling, right?
Yes, above false ceiling or below floor, because data centers and all you might have a false floor as well. So if the
Mm.
height is lesser than 800 we need not really worry about it as a separate detector for that. Clear?
Okay. Yeah.
Understood on it?
Yes, sir, understood.
Okay. But at the same time, if it's combustible, then we basically have it like wood or something. If there's a chance of fire there, then you will install it.
At the
Yeah,
two levels.
right. So that's the only thing that you have it. So anyway, this is a short note on your detect, like which could be avoided. That's the only location we have to avoid it. Rest all we have to place it in. So now, what we'll be doing is we'll be working on the design of this particular one. So I'll just close this off. I'll just freeze the ones that is not required. LAYTHW, including the graded furniture. I have it here. So I'll remove only the HVC layer. Okay, so that we can start placing all the detectors. Physical, civil as your this thing. Ducting also I don't require it. Detectors I'll place it so that because the diffusers I wanted because the location of my detector is dependent on that alva. Okay. Okay, so I'll leave it like this. So for this, over this we'll start working on. Yeah.
Yeah.
So now we have to work on the detector. So first I'll do one thing. I'll place the detector. So first we'll place the detectors, then we'll work on the MCPs, and then we'll work on the location of your fire alarm panel, and then we'll be working finally on your the wiring part. Is it fine? Madhu, you there? Hello. Is not there, is it? Is it?
Madhu, sir, we can't hear you.
No one is there. You can
Yeah, we
message
are.
if you're not available. Oh, okay. You're there, right? Okay. Yes, we couldn't hear you. That's it. Anyway. So we'll be working on. So you've got any queries till now? You can type it actually. Yes, I could see your hand, but if you have any queries, you can type here. Oh, okay, cool. See, any queries as such or nothing? Okay, fine. So now we'll be continuing with your detectors. Okay. So I'll create a new layer for this as detector. Fire alarm system detectors. So I'll use a different color, so probably the green or anything.
Sir, do we have any section for this plan? Like, what is the fall ceiling height?
Yeah, this I made it for this because this is again a project that I have created it, so it's up to us. So yes,
And
I've made a
yeah,
section
that.
here like this.
Oh,
Okay. So we'll place it above ceiling, below ceiling, response indicators, everything will show. So here this thing is simple. So what we thought is we have two types. One is basically like, you have a false ceiling everywhere, and then only the center portion is a grid ceiling, which is also part of a like, type of a false ceiling anyway. Okay, so you've got a gypsum ceiling and a grid ceiling is what we assume. And we have toilets. Toilets, I didn't do any bifurcation. Let's say we have got merino partitions where, like, though you have a false ceiling, you don't have full height walls, right? You can have up to 2.4, like, around 8 feet height or something, 8 and 9 feet height, something, 8 feet height as your 8 feet or 7.5 feet as your height of your, partitions inside your toilet for WC, water closets. Is that fine?
Okay.
Okay, I'll create a small circle. This, I'll write it as a detector. I'll write it as, so generally we call it as, uh, like, above false ceiling detector and below false ceiling detectors will write AFC, and below BFC is what we generally write it. But in this case, I'm just writing it as A and B so that it fits in the circle. That's it. A is above false ceiling. B, I'll change the color to pink or something. That I'll write it as B, which is below false ceiling detectors. Okay. So here I've got some beams as well, but that's okay. We'll avoid it as of now. So above false ceiling detectors. Then we go to B, which is below false ceiling detectors. Okay, now I have to place these detectors in a C 1.5 times increase the size of this. Now I have to place the detector. So first we'll work on below false ceiling detectors. Okay. So first we'll start with reception, let's say. As I've told you, the distance should be, the distance between two will be 7.5 meters is what we have to take it. So 7.5 meters means this is in feet anyway. So 7.5 into 3.28 and there is 24 feet. 24 feet we'll draw it. So one is actually sufficient, Alva, in the center reception. Yes or no?
Yes. Yes.
In the center reception, one is sufficient. So in each room also one is obviously sufficient and you not worry. So according to your other fixtures like light and all, you'll align with them, making sure your RCP is not really that bad. In this room, let's see. Five into 3.28, that's around 24 feet. Again, so 24 feet. So it's better we take this guy at the center. Yes, but I have your air. So between that, I shouldn't have between 1 meter. You agree?
One.
So
Yes.
1 meter is 3 feet, 4 feet, let's say. So I'll place it over here. So even then, this is sufficient or not?
Yes. Sufficient.
But yeah, so we can place it over here. Or if I wanted to be safer here, because I have a cassette AC anyway, we'll try to place one over here. And as a distance can be up to 24 feet. Anyway, the 24 feet means it will not cover. That's okay. In this space also one is sufficient. We need not worry. And then we'll take it over here again. So here we'll start it. So as I've told you, you should not have 1 meter as a minimum gap that you should have it. So let's take it from this corner. Return you can always have. It's only near the supply you shouldn't. The gap between the both should be 7.5 meters. Again, the other clause which is confusing. So 7.5 meters means I can have it one over here. Right?
Yeah.
One detector over here, one detector over here. And then we'll try to place that definitely this is lesser than 7.5, so we need not worry. Or I'll do one thing, I'll try to place it something like this. We'll place one over here. Now this location might not work out. Let's figure it out. Okay. We placed one over here. So now what we'll do is this one and this one will copy it, circle. What is the radius we have? 24 feet, right? Yeah. So I can have it one over here, one over here, Again, I'll copy it from this corner. I can take it over here or not?
Yeah.
Right. So, but this is not valid. Why? Because it is near 1 meter. It should be lesser than 1 meter of your this one. But now, don't you think it is like, don't you think it is lesser than 1 meter from your supply duct? Can I have it like this?
Um,
At
Minimum
least
one
between
meter
supply
distance
air
should be there.
diffuser or supply air grill to the one, at least I should have 1 meter. So what I'll do, I'll try to place it across. 1 meter means 3 feet, means if the two tiles, I'll put it like this. Is that fine?
Yeah.
I'll shift it across. What's the big deal? Okay, again, I'll take this guy and I'll take it over here.
Sir, but near this red one,
Hmm.
There,
That is return air diffuser.
okay, there we can
Return air
get
you can have.
inside.
It's only near the supply you shouldn't have. I've clearly said the rule. That's the reason. Even it's mentioned also in the IS code. It should never be near the
like,
supply air grill. Ashton.
what is the reason, sir?
Because supply
Yeah.
air grill from the AHU air will be coming out into your room space.
Okay.
So if the fire is inside the room space, basically the smoke should enter into your AHU. Anyway, it has got a filter. That filter will clean, and then you have got your cooling coil. The dust might settle over that, and from then it should enter into your space. So what will happen? It might not detect fire, though there is a smoke. You agree?
Okay. Yes.
But return air you can always have. The reason why return air you can have it is your return air sucks the air from your room space only.
Room space.
So if there's a smoke, it's high likely that it will pass through this diffuser if you keep it adjacent. In fact, it's very good if you keep it near the return air.
Yes.
Understood or not?
Yes, sir. Yeah.
That's a beauty of your, like, placing it near your return air diffuser. Yeah.
Okay.
Ah. Yeah. So that's the thing. So that's the reason you can place it near return air diffuser, but not near supplier. Understood?
Yes, sir.
Okay. So we'll try to place it over here. Oh, sorry. This one will take it. Again, we'll take it from here to this is reaching this point, means I can place it over here. Right? But again, in this case, either I have to shift it over here or here. Because again, it is near Alva, Adhika. Understood? Right? So I've placed it over here. Just a sec. Is it covering till the wall or not? I thought not. Yeah, we are able to cover it, so not a problem. Then again, I have to place it near this guy. Practically, no one does it, as I've told you. Most of the people, they just copy it from, like, they keep 7.5 meters distance without thinking about supply or return, which is against the rules anyway. Okay, now I've made it like this. And then what is the distance again? We've got it. From here, again, I can place it, sorry, circle 24 feet, Alva.
Yeah.
4.5, but anyway, that's okay. So now again, we'll take these two things and then we'll try to place it at this. Okay. Probably have to place it at this. From here, we'll take it. Copy. From here, I'll take it from this one to near to this one. I can place it. Right?
Yeah.
We place it over here. Then hopefully this have covered. If not, we'll try to take it from somewhere. Yeah, this is covering till this corner. So we are safer. You agree? This is covering this entire area, Alva. So we need to do this could be covered by this game, and within that 7.5 meters, it should reach. That's it. So you have it over here, something like that. So this is okay. Or safer, if we really wanted to be safe, you just place one more at this location because this corner smoke travel might not be. We'll place one at this location. Ashte, ಜಾಸ್ತಿ ಅನ್ಬೇಡ. Is this fine? So we have placed the detectors at all the spaces. Now, don't you think we have to do it in this conference room?
Yeah.
So yeah, this will not be smoke detect pantry. Okay, this is
Heat
not cooking,
detector
no.
will be there.
So you get heat detector is preferable, but again, general lunchrooms and all, you don't have any steam because if you have cooking, yes, it's important. But general pantry and all, it's not that you will cook there, right? You'll just bring lunch boxes and you'll open it. You'll not have any like smoke because of it. So that you
Sir,
can ignore it.
what if we use this electric stove?
Then also you should consider heat detector because electrical stove means it's not the
Mm,
burning gas that gives you. It's basically the food that is basically boiling will give smoke.
mm, mm,
So irrespective of the type of stove, you take it as a heat detector. Understood?
mm.
So 1 meter I should have a gap. 1000 mm. Oh, sorry, this is feet, alva.
Heat.
So 3 feet, 4 feet. I'll take for example 4 feet. So one detector is sufficient here. And in this case, again, probably one is sufficient.
Yeah.
Hmm. So one is sufficient here. 7.5 meter radius. 24 feet. 24 feet. Yeah, covered. Then similarly, we can take it here as well. Female toilet one, male toilet one. Placement. So we have placed all the detectors below the ceiling. Understood. And of course, we have got a server room which will require
Sir,
this. Yeah.
two rooms are like if two rooms are having minimum space only 7.5 meter, then we can place only one detector, or we have to place two detector
That's
in
what you
every
have
room.
two clauses. Any part of the ceiling should be within 7.5 meters.
Okay.
So I can always cite that rule.
Mhm.
Understood?
No, sir. My doubt is like in conference room we are placing detector. No, we draw a circle
In
of
which room?
7.5 meter
Sorry,
in
come again.
conference room, for example. Example for conference room only.
Huh.
If we draw a circle of 7.5 meter, it covers as well as the what's that room, sir? After conference collapse space.
Collapse
Uh,
spaces are yes.
uh, if 7.5 meter circle is covering collapse space also, then we can use only one
No, you
detector,
should not
or
because there's a partition wall, alva.
partition. Yes, okay,
So if the partition wall is there, you have to consider this a separate zone altogether.
done.
Obviously, if there's a fire in conference room, how will it enter into your collapse space? Or from collapse space, how will it enter into your conference room?
Yes, yes,
Understood or not?
yes, sir, yes, sir, clear.
Yeah. Check. So we have placed all the detectors for above the ceiling areas. Now we have to work on the next one, which is your above ceiling spaces. So if you wanted to really place above ceiling spaces, you have to have a beam layout. Then you decide it. And then we have to assume. So let us assume that there are some beams, if that's okay. So this is a section I've got it here. So let's assume we have got a beam over here. Just randomly drawing some beams. Okay, let's assume this is generally you have your columns. So using columns, you'll know whichever is a beam anyway. So first of all, let's see whether it's required or not. If the height is greater than 800 mm, then only. So 3 feet means it's almost 1 meter.
Mm.
So definitely greater than 800. So I require it above fall ceiling also. And your partitions might not touch your slab. You agree? Generally,
Yes,
what will
yes,
happen? The gypsum board will be screwed only till fall ceiling height, alva.
Yes.
yes.
So we need not worry. So what we'll do, we'll basically take this above fall ceiling one, except toilets, because only toilet walls will be block work, which we'll install it till the slab, and server room will take it separately. But rest all, don't you think it's required? It's not required, alva. So what we'll do, we'll directly take a gap of 7,500 mm.
Sir, we had one more condition there
Sorry,
where
one
the
second,
part
please.
where the
Hmm.
partition wall is not greater than 300 mm.
Partition wall is definitely like no, that one is if there's a partition is greater than 300 alva. So beam is what I've said. Beam, if it is greater than 10%, you have to consider it as a separate zone. Though in this section I've shown it, your only your supports will be reaching till the slab, but your gypsum wall, gypsum partition will only be screwed only till the fall ceiling height, alva. Most of the cases.
Yes.
I didn't understand
Yeah.
your point, Sir. Come again.
Sir,
300 mm, what you were telling.
yeah, that's what. From the slab, sir, from the
Hmm.
roof to slab, if the partition wall is,
Roof to slab means what is
huh,
the difference? Roof means slab means floor or what
Tall
you meant to say?
yeah,
ceiling to
floor to roof. I'm talking about
Floor to roof. Okay.
roof. Yeah, near the roof, if we have the greater than 300 mm,
We need not consider it as a separate zone.
yeah. But here the gypsum boards are below this fall ceiling level, right?
No, it will be above the false ceiling, beneath the slab. Generally, what will you have is, let's say this is your slab, this is your floor, and let's say this is your false ceiling. So room, like when you go to any conference room or anywhere, basically they should be able to see the partition, right? That partition will be made in such these are your supports, but your
Mm,
boards will be installed just above the false ceiling like this in most of the cases.
okay.
So what will
If,
happen above this? You have a lot of space, but beneath the false ceiling, it's completely enclosed. So beneath the
oh,
false ceiling, you have to treat it as a separate room space, but not above. Understood or not?
mm, yes, got it.
Yeah. Everyone is clear now?
yes, sir.
Okay. But anyway, these are the beams I've got it. So now what I have to do is I have to consider it as a separate space altogether. But vertically, let's say I've got only one beam at the center. I'm just assuming it, that's it. So let me assume this is my room layout. If I wanted to place a detector, so this is my section. Okay, this is not the actual section probably. The section was something like this, if I'm not. The width is not matching, Alva. Okay, let us turn it like this. Actually, I've marked it wrong. I'll rotate it like this and then we'll do it. Is it fine? Yeah.
Sir. Yes, sir.
Yes.
Let us assume something like this because obviously this room is something because that's the reason it was matching. Just a second. Okay. So this is your, yeah, this is matching. So here you've got a beam in the corner. Here you've got a beam in the corner. This is the beam layout. That's it. So this is one more beam you have got it here. One more beam over here. Beam layout is really important for us to mark the upper false ceiling detectors. Understood or not? You've got it something like this. And then along with this, you've got one more, detector. Let's say randomly over here. Obviously, in the corner also, you'll have a beam alva, most of the cases. So here I've got a beam, let's say. And let's say here I've got some beam over here and probably a beam in this corner. So shall we consider this as your beam layout for understanding? Yes or no?
Yes.
Okay, this is your beam line. So now if I wanted to place your detector, beam here, you can see it. What is the height I have got it? This height is only 3 feet. In that, this particular beam, here, the height is how much we have it? Sorry, height of the beam, I have to mark it. Really sorry. So height of the beam is 2 feet. So in 3
So,
feet, 2 feet means greater than 10% or not? Definitely.
sir,
Yes or no?
height of the beam will be from the slab, right? Or the we
Yeah,
will just consider only the projection of the beam.
from the slab only. Means from the slab means from here, right? We have to take it.
Okay.
Why should
No,
I worry about the
usually,
slab thickness?
okay. Only the
Yeah,
projection of the
structural
beam.
drawing, it's different. In structural drawing, we will it include in the floor because for reinforcement and all, you require those details. And here, why do we want it? A slab is
Okay.
again closed, alva. LR.
Okay. Why I asked this? Usually, while considering the beam depth, we will consider completely, right? So that's.
That's what for structural drawing, yes. But
Mm,
for us, minus the slab is what we have to consider, right? Because anyway, the slab is the slab is including the thickness of the beam, alva.
yes.
Okay.
Uh,
Excellent
Sir,
understand.
you were
Padindi
saying
kada.
10%.
Yeah, so in the total height, what you have it, the beam height is greater than 10%, alva, in that
10%
particular
means
void
like
space.
if we are having false ceiling of 800 mm, so 10% beam you are telling, right?
Yeah, if it's more than 10%, yes.
Okay, okay, okay.
You
Definitely
have
it
to
will
consider it
be.
as a separate zone anyway. That's what
Okay.
I've told you. 99.9% between the false ceiling and the slab, the beam height is
Yes,
anyway more
yes,
than 10% is what I've said. 99.9% of jobs.
yes,
Understood?
yes.
So your detectors will be at this location. So in this zone entirely, I can draw a circle of 7 point. I'll draw 7.5 meters means 24 feet. I'll draw a distance of 24. I'll mark it with different color. Yep. So I'll this particular one. Sorry. Anywhere I can place it, there's nothing wrong because the entire zone is single thing for me. If you place it also, I'll not be able to cover. So in this entire zone, I require two numbers. Above we require one, and here also we'll place one. Okay. Similarly, in this zone also, we'll take two detectors are required here. Two detectors, we'll place it over here. Okay, and here also we'll try to copy it from. Okay. This entire zone, probably two are sufficient. Let's hope. No, it's not covering two, so we'll place four numbers. Is that fine? Oh, sorry. This is this circle, Alva. This circle, this, and this way. Yeah, copy two wrong circles. If I take it, I'll not be able to. Yeah, I'll be able to cover the entire zone or not with two numbers. Yes. Yeah, I'll remove the circle for your inference. You can see this have covered the entire. I'll draw it the other color. Just a second. So in between this rectangle, don't you think it has covered the entire area?
Yes, sir.
That's a reason. The two are sufficient here. So we have taken it over here. Copy.
One is
Which one?
no, on the other side, one will be sufficient.
I didn't understand. Sorry. Come again.
No, no, sir. Here, near this W,
Hmm.
we have left out, right?
W. Which W?
No, no, no. This on the left hand side, we
Okay,
have
left
left.
hand side, yes.
Uh, no, we after that circle, sir, we have left out even there, right?
Yeah, we have, but we can't use it because this beam is like obstruction for me. So only this rectangle is what my isolation chamber I have to
Oh,
consider.
okay, okay, okay,
I've told you,
okay.
no, because the beam
Yes,
height is greater than 10%.
got it, got it.
So here also we'll place two numbers, which should be sufficient. And then again in this zone, I have to take it separately. Alva?
Hmm.
Sorry, this one I have to take it separately, this one and this one. Copy two numbers, sorry. Select some and remove the circles. So obviously in this case also require two numbers,
Hmm.
right? And then here also we'll take some two numbers. So this look okay, female toilet and male toilet, we'll take consider it separately. Though we have got a beams, we have to consider it separately. The reason is generally the block work will be like till the slab we will connect it to your toilets, right? Or you don't want any foul smell. Yes or no?
Yes.
Yes.
But as per you, so if this wall is touching, this entire zone will be considered separately or not? Because of the beam connectivity, what will happen? This entire zone, I'll just draw a
Yes,
polyline
yes.
here.
There we have one required.
50, 50 if we take it. So this entire area, don't you think I'll take it as, I have to consider it as separate zone or not?
Yes.
Right. So this is a blind spot for the detector. So here I have to place one more detectors, one or two more detectors. So one detector will place it here, two detectors if I place it also, it should be sufficient. Understood or not?
Understood,
Okay,
sir.
clear.
Yeah. And here much move might take a lot of time. So in this zone also, I'll place one more at this location for me. So that's how, according to your beam layout, you have to decide your detectors. Understood or not?
Yes.
Clear.
Understood, sir.
Yeah. So you could say it's not uniform, but if you mark the beam layout, then you will understand how I've created or above fall ceiling. Am I clear?
Yes.
Okay. So then we have to place your MCP and we have to do the wiring connections to it. So shall we continue from tomorrow else? That's fine.
Yes, sir. Okay.
Sir,
So
yeah,
tomorrow we'll place the hooter, we'll place your MCP, and then we
MCP.
will start with the wiring connections. Okay?
Yes, sir.
Sir,
That will be
sir,
part
for
two anyway.
commercial, we have understand. For residential also, same considerations will be there, no?
Yeah, if required, but